Hello guys, today we're going to solve this Leetcode question which is furthest building you can reach. This question, you're given an integer array heights representing the heights of buildings and some bricks and some ladders. You start your journey from building 0, start your journey from building 0 and move to the next building by possibly using either bricks or ladders, right? And while moving from building I to I plus 1, there are two options for you. You can either before that, look at this. If the current building height is greater than or equals to the next building's height, you do not need a ladder or bricks. What it is saying is, suppose you are here and you want to go to another building which is of the same height or below you. You can you may not choose. You may or I'm sorry. There is no need to use any sort of bricks or ladders, right? And if the current building's height is less than the next building's height, if the current building's height is less than the next building's height, you can either use bricks or a ladder, right? And return the farthest building that you can reach if you can use given ladders and bricks optimally. So we just need to make use of these bricks and ladders optimally so that we can reach the farthest building possible. That is the question. Let's look at this example in order to understand. Suppose I'm at here, right? Suppose I'm at here and I want to reach the farthest building possible. Suppose I'm given 5 bricks and one ladder, right? So when I'm here, I see that the next building is on the bottom, right? It's on the bottom. The height of the next building is less. So I'll just directly jump here. I will not use any bricks or ladders. So from here, I see that my next building is, greater than, is taller than my current building. So what I'll do is, I'll either use bricks or I'll either use ladders, right? And from here, there's no need to use any bricks or ladders. I'll just directly jump here. I'm a Krish, and from here, I'll either use bricks or ladders, and I'll either use bricks or ladders. I'll directly jump. That's it. Now let's see this with an example. So let's go through this example in order to understand the question more clearly. Suppose initially I'm here. So my next building is shorter than my current building, right? So I'll just directly jump here. I'll just directly jump here. Now I see that the next building is taller than me. In this question, in this example, we have a number of bricks as 5. Number of ladders as 1, right? So in at this point, I can either choose bricks or I can either choose ladder in order to get on top of this. A ladder can help us to climb, you know, any building. You know what I mean? Like you can climb any building of no matter what's the height of the building. But with bricks, you have a limit. You can only climb. You can only climb 5 bricks because we only have 5 bricks, right? So the difference between two buildings should be less than the bricks. So for ladder there is no limit but for bricks there is limit. So if you look into this situation, we have 5 bricks, right? So what I can do is, I can use bricks, right? I can either use bricks or a ladder. Using ladder, I can also come here, and using bricks also I can come here because the difference between 7 and 2 is 5. So I need 5 bricks in order to come here, and I'll use my bricks. So my bricks will become 0 and I'll have one ladder and I'll be here, right? I'll be here, and from here I see that this building is shorter, so I'll directly come here And from here, if you see that, this building is taller, right? So can I use bricks? I don't have any bricks. I just use it bricks here, right? I use it bricks here. So I cannot use any bricks, but I have a ladder, right? So I'll use a ladder. I'll use a ladder to come here. So I came here. When I came here, my ladders also became 0 and my bricks also became 0. So I cannot use any bricks or ladders right now. So can I get here? I don't have any bricks or ladders, so I cannot go further, right? So this is 0, this is 1, this is 2, this is 3, this is 4. So I can reach up to fourth building. So our answer is 4. So after looking at this question, what's the approach that came into my mind is that, you know, if I'm at, you know, just a second. If I'm at a building, I'm at this building and my next building is shorter, I'll just directly go to that building. But when my next building is, taller, I have two options. When my next building is taller, I have two options. Either I can choose bricks or I can choose a ladder, right? Either I can choose bricks or a ladder. And what I thought was, after going to this building, after going to this building, I can directly jump to this building, right? I can directly jump to the next building. And from here, I again need to go up, right? So I again have two options. I can either use ladder or bricks in order to go to the next building. And from here again I have to go up. So again from here I have two options. So I thought I it is easy to use. It is what they call. It is. um, I thought we can use recursion here, but if you look at the constraints, we need to keep track of we need to keep track of the number of bricks, and we also need to keep track of the number of ladders. The number of ladders again can be height dot length, which can be 10 power 5. So the dimensions can be very large. They can be 10 power 9 into 10 power 5, which is not possible. This will throw us memory limit exceeded, right? This will throw us memory limit exceeded. So we cannot use recursion, and further we cannot memorize it in order to optimize it. So we need to think of a optimal way without using recursion and memorization. So what we can do. So the second approach that came to my mind is, you know, the second approach is, I'll, you know, I'll give preference to bricks initially. When when I'm not able to use bricks, that's when I'll use, ladder. This is what came to my mind, when I understood that I cannot apply recursion in this question. So at this point of time, there is one test, there are so many test cases that will fail if we use this method, but I'll give you one test case that will fail miserably. you know. Now, if you look at this example, I said, I'll give preference to bricks, and when I'm not able to use bricks, that's when I'll use the ladder. So let's try to apply this thing in this question, in this test case at least. So I'll be starting here, right? So I see that the next building is 4 bricks or 4 meters taller than the current building, right? So I have 4 bricks. So I can use 4 bricks and 1, 2, 3, 4, and I can reach to the top, right? So my the total number of bricks become 0. I'm sorry. The total number of bricks will become 0, and from here I can directly come down. We all know that, right? And from here I see that, you know, I don't have any bricks, so I can only go to this by using one ladder. One ladder. So my number of ladders has also become 0. So I see a taller building right now, but I don't have any bricks. I don't have any ladders. So I cannot go further, right? So I can only reach up to this building if I use bricks initially. So let's try to solve this in an another way. Let's try to solve this in an another way. Now, suppose if I'm here and I have number of bricks as 4 and number of ladders as only 1. So what if I use ladder for this? I've used one ladder, so this will become 0. So from here I can directly come here, we know that. And from here I have 4 bricks, right? From here, I can reach up to this building by using one brick, right? From here I can, then the number of bricks will become 3. And from here I can reach to this building. So now the number of building bricks will become 2. And from here I can reach to this building and the number of bricks will become 1. So by using this method, I'm able to, I'm able to reach the last building, right? So this is more optimal compared to this thing. So what's the takeaway in this thing is, what's the takeaway is, so by looking at the above example, we might think that, we'll use ladders first, and when the ladders are completed, I'll use bricks. So we might think that. But if you look at this test case, I'll try to use ladders first and then the bricks, right? So initially I'm here. From going from here to here, I'll use a ladder. So number of ladders will become 1. And from here to here, I'll use a ladder. Number of ladders will become 2. From going from here to here, I'll use a brick, right? So the number of bricks is 3. So from here, I cannot go to here, right? So the difference is 6, but I only have 3 bricks. So I cannot use bricks and I'm out of ladders as well. So I cannot use both. So I'm stuck here. So let's try to solve it differently. So initially, just a second, the number of bricks equals to 4, the number of ladders equals to 2. So initially when I'm here, if I use one brick, I can come here. So I'll have 3 bricks. If I'll take another brick and I'll come here. So I'll have 2 bricks and I'll take another brick and I'll come here. So I'll have 1 brick. So from here, I cannot use bricks, right? So I need 6 bricks, but I only have 1 brick. So I'll try to use ladder. I can use ladder and I can come here, right? So 1. I can use ladder and I can come here. So my number of ladders will become 0 and I'm able to reach to the last building. So with this we can understand that, there is no point in giving preference to bricks and there's no point in giving preference to ladders as well. So by these examples, we understood that we cannot give preference to bricks first, and we also cannot give preference to ladders first. So how are we going to solve this? We cannot give preference to bricks and we also cannot give preference to ladders. So how are we going to solve this means, we need to understand the use cases of both bricks and ladders. When the difference between the buildings is less, we'll use bricks. When the difference between the buildings is high, very high, then we'll use ladders. That's when we can use both bricks and ladders optimally. So how are we going to do this? So how are we going to do this means we'll use a priority queue. A priority queue. So this priority queue will make sure that uh, so this priority queue stores the differences between the buildings while we are going from left to right. And initially we'll try to use ladders. We'll try to use ladders, and when we are out of ladders, then we'll take the minimum value from the priority queue and we'll try to use it for the bricks. Because for the larger values, we'll try to use ladders, right? We'll try to use ladders, and for the smaller values, we'll try to use bricks. So let's see how we are going to do that. So let's take this example itself. Initially, what's the difference between these two buildings? One, right? So one. The number of bricks is equals to 4 and the number of ladders is equals to 2, right? Then what's the difference between these two? Oh, let's again start from the beginning. I'm sorry. So let's suppose these are our buildings and this is our priority queue and we have 4 bricks and 2 ladders, right? So initially we'll try to use ladders. We'll try to use ladders, and when we are out of ladders, then we'll try to use for the small differences between the buildings, we'll try to use bricks, right? So let's see how we solve this. Initially the difference between these two buildings is one, right? One. So what I'll do is I'll try to use a ladder, one, right? So then the difference between these two is again one. So I'll again try to use a ladder, right? And the difference between these two is again one. But when I try to use ladder, I cannot use, right? Because I have no ladders. So right now I'll try to use bricks. I'll try to use bricks for the smallest difference between the buildings, right? So what is the smallest between these values? One, right? So I'll take this one and I'll reduce. So it means I used a brick here, right? So for this, I'll remove this thing from the priority queue because I have used a brick for this building and I have used two ladders for these two buildings. Now again, we are right here, right? So we'll try to go from here to here. The difference between these two is 6, right? So this is 6. So I can only use two ladders, but right now I don't have any ladder, right? I can only use two ladders. So I will use ladder for this and I'll use ladder for this. For this as well, I'll use a brick. So I'll remove this thing from the priority queue. I'll use a brick. So this will become right. And from here, I'll again go here and the difference will become 5. But I don't have any ladder, right? So I can only use two ladders. So I'll remove this thing from the queue and I'll use a brick. See, so what we're actually doing is initially if we are having buildings like this, if we have buildings like this, initially what we're doing is we're trying to use a ladder directly, right? And when we are going down, we're just going down as it is. And from here, we're again using a ladder and again using a ladder. And when we see that we cannot use a ladder, we'll go back and we'll find the smallest difference between the buildings and we'll try to use a brick there. We'll try to use a brick there and use the ladder for the tallest one. So let me take another example. Now let's solve this example in order to understand the approach better. So we have three ladders and we have three bricks, right? So and we and we have our priority queue right here. Initially I'm right here, right? So initially I'll go here by using a ladder. So the difference is 9, but the ladder doesn't care about that. So the difference is 9, right? So I'll use a ladder. So the number of ladders will become 2. From here I can directly come here without using any ladder or brick. That's okay. Then from here I'll come here by using a ladder, right? So the number of ladders will become 1. From here as well I'll come here by using a ladder. So the number of ladders will become 0. So from here I'll try to go here, but I have only 3 bricks, right? But I need 5 bricks in order to go here, so I cannot do that. So I'm sorry. So what I'll do is when I'm coming down, I'll not add it to my priority queue. When I'm going up, I'll add it 1. So it is 9. This is 1, and this is 1. So right now, this is our priority queue. So when I'm right here, I cannot go here, right? By using my ladders, and I cannot also go by using my bricks. So what I'll do is I'll find the smallest one. So we see that this is the smallest one, right? And I'll try to use bricks for this. So instead of using a ladder, I'll use a brick here. So I'll take the smallest one from the priority queue and remove it, and I'll use a brick for that, right? And again, so I have one ladder left, right? So my number of ladders will become 1. So I'll use a ladder right here, right? So the number of ladders will become 0. And again, from here to here, I need 5 bricks, but I only got 2 bricks. I don't have any ladders, right? So I'll try to again go back and try to use a brick here by removing the smallest one. So I have added this one. I forgot to add this one. Is 5, right? 5, and we got 1. So right now we're removing 1 and we're adding a brick, right? We added a brick and we can add this one right now. So this will become 5. So using these, so we're basically what we're doing is we're just using ladders for the larger differences, and we are using bricks for the smaller differences. So let's see how we are going to solve this question. We don't need this code, so we just need this code. We can use the count from 0. So this is our code. Initially, my count is nothing but the number of buildings I'm crossing. That is the count. Initially, my count is 0, and I'm declaring a priority queue, and I'm starting from the first building. Starting from this building, and I'm checking the difference between these two buildings. This is greater than 0. Means the difference between these two is greater than 0. If it is, if you look at this example, if the difference between 3 and 14 is greater than 0, that means the next building is the ith building is greater, right? So that's when we're adding it to the priority queue. Adding it to the priority queue means we are using a ladder. So if the number of ladders that we are using in the priority queue goes more than the number of ladders that we have, as I have already said, we will remove that from the priority queue, and we see whether we can climb it by using bricks or not. If we are able to climb it with the help of bricks, then we'll come back and we'll reduce the bricks and we'll increase the count as well. If we cannot if we cannot climb the building by using bricks, we'll just return the count. That's it. I'll just run it. It executes fine. It executes fine. And that's it for the video, guys. Thank you for watching.